Hello 8th graders, your new video is on section 8.4, which is on transformations and congruence. So transformations, remember that can be a translation, which is just sliding it from one place to another. It could be a rotation, it could be a reflection, any of those that we've covered so far. And then remember that the word congruent means equal, okay? So on these ones, it says, if you can use a sequence of transformations to map one figure onto another, then the two figures are congruent. So a series of steps, in other words, to get from one to the other, then they would be congruent. So let's see what it says down here. It says the three trapezoids are congruent. Describe the sequence of transformations that maps WXYZ onto the second one, or the third one, W, X, Y, and Z with the little 2. So how are they getting, they're basically saying, how are they getting from this one to this one? And you have to describe how they're doing it. Well, they can't just go from here to here, because you can tell that this side matches up with this. I labeled those wrong. That should be an X and a W. Okay, now, how do I get from this first one right here, my pre-image, to this one, which is actually the second image, right? This would be the first image, this would be the second one. So the first thing you need to look at is, they're telling you they are congruent, so that's not the question. The question is, how do they get from here to here? Well, how do they get from here to here? They're both 1 away, they're both 1 away, they're both 4 away. You can kind of see that this side just flips, right? So it, what's the word for that? A reflection over the X, over the Y-axis, excuse me. The Y-axis is this one, the X is this one. So it's a reflection over the X, the Y-axis, that maps this one onto this one. They're going to let me do what I'm trying to do. Okay, then you need to look at, how are they getting from this one to this one? Well, X stays in the same corner, Y stays in the same corner, Y and Z, excuse me. So it's not reflecting, because if it was, this XW would have to be down here. It's not reflecting, it's not rotating, because it's not twisting at all. It just looks to me like it's sliding, right? So if X is going from here all the way down to here, how many is it moving? 1, 2, 3, 4, 5, 6, 7, it looks like. So a translation 7 units down maps W1, X1, Y1, Z1 onto W2, X2, Y2, Z2. Right? So let's just recap that real quick. This one flipped across this axis first, reflection, and then it just slid down that way. How about this one? It says determine whether triangle EFG, so this first one right here, is congruent to M and P, which is this one. It says if the triangles are congruent, tell what sequence of transformations will map triangle EFG onto MNP, and then write a congruent statement. If they are not congruent, explain why they're not. Okay, well, you can see that they're all the same size. That's not the question. The question is, how in the world do we get from this triangle right here to this one, right? So you've got to you've got to figure it out. It's just kind of a guess and check thing, right? Do I take it and flip it here first, or do I take it and flip it here first? Which one kind of looks like it could be either one, but it's only going to work one way that you do it. Okay, so given the fact that if we move it over here first, if we reflect it over here first, then how do we get, you could just translate it here, but it also has to go here, so then that makes sense that it wouldn't go here first. It's not going to work. It has to go here first. So we're going to say that it reflects across the x-axis first. So it's going from here and flipping down to here. That's going to be step 1. Reflection over the x. So now it's right here. It went from here to here. And I can't just go straight to here. Obviously, I've got to go to here first. So how are they getting there? It's upside down on this one, and then it's straight up on this one. Looks to me like they're rotating, right? If we rotated it 90 degrees counterclockwise, it'd be here. Rotated it another 90, it'd be there. So we're rotating it 180 degrees around the origin. Once I get it over here, then I'm just sliding it down. Translation 6 units down. So those are my 3 steps, right? So let's look at those again. I'm starting here. I'm reflecting across the x. I'm rotating around the origin 180, and then I'm translating it down. And writing a congruent statement, remember, congruence looks like that. So triangle EFG is congruent to triangle MNP based on the fact that these 3 steps right here map this triangle on top of this one. It's a series of steps. So we're not just doing one step like we were before, we're doing a series of steps. So bring that knowledge with